Everyone should also be able to take a book and read how do we make intelligent system. I don't believe a lot in many of these AI tutor thing. I want a future where AI make us more human. We're more happy to be human.
Yeah.
Very soon, when you call someone, it will be indistinguishable if this video you're seeing is real or not.
Just to clarify, this podcast is real.
We're not AI generated.
Hello, everybody. My name is Jagat. And my name is Janak. We're both twins at Stanford and co-hosts of the Starts podcast. Today, we are very pleased to be joined by Thomas Wolf. Thomas is the co-founder and chief science officer of Hugging Face, a platform that aims to democratize machine learning and artificial intelligence through accessible and open source models and data sets. Prior to co-founding Hugging Face, Thomas studied superconducting materials and laser plasma interactions, receiving a PhD in physics. He also received a law degree and worked at an intellectual property law firm where he consulted for various deep learning, machine learning, and AI startups. Thomas, thank you so much for joining us today. It's a huge pleasure to have you on the podcast.
Thanks for inviting me.
Great. For today's conversation, to start, we'd really love to learn more about your diverse educational background in starting Hugging Face and sort of what led you, with exploring physics and computer science and sort of leading to, analyzing the intersection between those two. So for our first question, growing up, you received a degree in physics from École Polytechnique. You studied statistical and quantum physics as well as law and business. And so we'd love to learn more about sort of how these different fields shaped your perspective. I think I was reading more about, really, really admire how, when you were looking at these sort of AI machine learning startups, you actually realize a lot of the math was, driven from physics. Mm-hmm. So I'd love to learn more about perhaps maybe the different inspiration or sort of what sort of visions you encountered as you were approaching the beginning of Hugging Face.
It's it's always hard to, really, I think, understand how you would have been if you took another path. I know for myself, so you have to picture also yourself that in the 90s, AI did not really exist like AI, right? I had no artificial intelligence class. So it's maybe if I grew up nowadays, I would directly go to AI. Right?
Yeah.
For me, I had no idea this thing existed.
Yeah.
I was like, I like math. Computer science was not yet like a job really. They had this like Amstrad PC. It was like, and so really, I was looking for something in math, and math itself looked a bit too difficult for me, like research in math. So I was like, yeah, physics is maybe good. So that's why my first track was physics, and I really enjoyed that. But I also discovered that physics experiments and real life experiments are just really tough, right? They take a long time.
Yeah.
Most of the time, they just don't work. They just they're annoying. Real life is annoying, right?
Yeah.
And so during my PhD, I was like, it's really tough. You need also to have so usually physics experiments go like that. You will have an idea.
Mm-hmm.
Then you will find grants basically to pay for instance, the cryostat that we used for cold temperature superconducting materials. That's what I was working on, which was basically what today is quantum computers. I was doing this kind of Josephson junction, which is one way to do qubits. And this thing costs 1 million. So you need to find money, you need to buy it, then you need to build it. It takes like also 1 year to build, basically.
Right.
And so the whole experiment was basically 3 years. And then you discover at the end if your idea was right or wrong. And a lot of my idea was just not good idea. So I was like, back on the on the desk and having a new idea. And so like, I don't know if I can do 3 experiments in 10 years. Yeah. Maybe also I was young. I wanted to move fast. So that's why I was like, okay, maybe physics is not for me. I need something that moves faster. Yeah. And I really liked a lot of things. I really liked writing as well. So that's why I was discussing with a good friend who was a lawyer. I was like, we write a lot as lawyers. So why don't you try? Like, okay. And so I took an evening class in law and I became a lawyer. Yeah. And I liked that a lot as well. It was really moving much faster. You had a lot of cases and people coming and you feel very helpful because you're like helping them. You're very an expert in the field. And at the end, I really started to have this pool of startups that I was helping quite a lot. And some of them were starting to do deep learning. And that's basically where I discovered that what deep learning was and what machine learning was. Wow. I was writing the patents for them. And I was like, okay, this is really same equation in a way, right? Like instead of minimizing free energy, you're minimizing loss, so you're maximizing probabilities, whatever, how you see it. But that's really the same math. I was like, that's cool. And the experiments, they look a lot faster. It's not 3 years, like 2 weeks or a month. So I got really excited about that. And I would say on the side, I've always been enjoying programming, always as a side hobby. But like the perspective of making it my main occupation was very attractive as well. So that's a bit what brought me there. Yeah, quite of a complex path to end up doing what I do.
And would you say, to a certain degree that, your discovery of AI and machine learning through these portfolio companies from more of a law-based perspective, did that open your eye to a lot of the ethical implications of AI? Because I feel like a lot of startups tend to, make these solutions or products, but they aren't really considering what are the ethics, how can we, ensure fairness or transparency. So I'm more curious to learn perhaps about how that sort of law-based vision may have tailored your introduction to machine learning.
Yeah, it's possible, right? I've never really. It's hard to know because I would need to compare a version of me who didn't do law, a version of me who did. But that's for sure. Law is all about studying, the impact on society of something we build, which is law. And that's all the things. It's case studies, and you see, oh, this actually brought this person to this, and then we should change the law because that's not good, or we should add something, or we should actually take into account these real life cases. So it's all about real life stories. And I think that's probably something I kept in my computer science work right now, which is there are humans behind all these algorithms that will use them and that will actually change in good or bad in their life. And so I think the first thing is for me is and in retrospect, I think that's where I don't think I'm a very good programmer. There's a lot of much better programmer at Hugging Face now, but I think I'm pretty good at defining user interface, like how people will use my software or the software we build. And this is all about thinking about people that are using your software. About that. Yeah, maybe this is kind of a very low or like social science aspect or something like that.
Yeah. Can you walk us through your process on how you go about designing, the user interface?
Yeah, it's most of the thing. So even the start of the project starts usually with me seeing the type of user experience I want to see, the type of user interaction I want to see. Even very all the libraries I've helped at Hugging Face, which are transformers that I've mostly built myself, data sets that are the two I built really myself. Accelerate was one I strongly pushed for the IDE, and diffusers was also another one. And all of them, it starts with this IDE. This is the lines of code I want to write, and this is the effect they should have. And now let's build the backend that's render that make all of this possible. So you start there, and then that's usually the first part, and then you build a lot of things. And then the last part is also very long, is before you release, you play with things a lot. You try all these cases, you try all this thing, and maybe you adjust actually, because often it's only when you start to really have the thing built that you can really play with it and really fully understand how people will use it. But this last part is also quite long. It's actually a few days, and sometimes it change. And sometimes you decide, actually, I want to change completely the API. There is something that's not natural. It has to be extremely natural. The perfect library for me is one you don't even need to take a look at the doc. It's so obvious how you use it. That's and that's cool because nobody really reads the doc or nobody really wants to read it, right? So anytime you're like, okay. So you should have for instance, you should have a very small number of abstractions. If you need to list 10 abstractions, you need to learn before you use a library. It's annoying, right?
Right. Yeah.
So you should have, I think, 2 or 3 abstractions is the right level. They should be very intuitive in terms of almost non-programmatic, non-software developer minds. You should almost be able to explain them to your parents who are not. Maybe your parents are software developers, but I don't think they're right. So I think transformers, I could even explain the abstraction to my dad, who is a doctor.
Wow.
Maybe with a little bit of time, but so it should be to this level. I think.
That's a very important message. I think it's something you often see you can build the world's most innovative product, but if you can't convey its purpose, you can't convey its meaning, and you can't distill that into maybe like to the 10-year-old, then it's. I think Naval had a quote about, if you can build and sell, and if you can do both of those really, really well,
Yeah.
you'll be unstoppable.
Yeah.
Yeah.
Yeah, I think it's very true. Yeah. And usually selling is basically just putting yourself in the shoes of someone who wants to use your thing and explaining why they should use it. And it should be very obvious, right? It should be directly, oh yeah, that's exactly what I want to do. That's exactly how I want to do it.
Yeah. So you mentioned, starting off physics research, it was a very lengthy process. I'm curious to, know if do you think that current machine learning models are able to do physics or like have a good intuition of physics as to what you were studying, when you first started out, or do you think there's still a long way for us to make progress?
So I wrote recently a short essay on that. I don't know if it's
Einstein,
the Einstein AI models, where I explained that they have some limitation that I found very frustrating, and which are also similar limitation that I hit in my research, which was it's making the experiments. Okay, it's pretty long, so it's still very nice if we speed up a lot of the work you need to do, but it's only a very small part of being a researcher. It's maybe the one that take the longest time, but it's a lot of engineering and just being very rigorous. But the tough part is which question are you exploring? Why?
Yeah.
And that's, I think, a lot of people who haven't done research really, they don't understand how this is crucial. They just think, oh, you just do experiments, but who gave you the experiments? Nobody. Well, when you're a student, when you're a PhD student, sometimes you're lucky you have a great PhD advisor.
Right.
And they say, oh, this is the question. And it happens to many of my friends. They had amazing PhD, great publications. And after that, they were like on their own when they became a researcher. It was very difficult. And that's the moment they understood that actually 90% of their success in PhD was due to their advisor having very good ideas around which direction to explore.
Yeah.
And this transition for many researchers also here, when I come and I see friends, professor at Stanford just join, you see this really difficult transition between being like a student researcher where someone helps you a lot in this general thing, and you still feel like you're doing a lot because you're building the experiments, and you feel like you're doing it all. But the moment you need to find yourself the right question to ask, that's a very tough moment. That's like maybe like a writer, in front of a blank page. You could write every book possible. Which one do you want to write? Yeah.
I think
so. To continue, I think models are very good at all these work once the question is asked. So they're very good at maybe giving you a plan for the experiments you should do, and very soon they will be able to be plugged also in maybe the machines to do the experiments themselves. But the real thing that will give us the future super relativity way to go, I don't know, faster than light, something like, will be someone just asking the right question. I think they're pretty bad at this.
Okay.
Yeah. It's annoying.
No, I think it's definitely, there's something that in a way, not knowing can allow you to ask better questions, I think.
Yeah.
You look at children, they're like, why is the sky blue? Or like, why is this, question everything. Why is it hard? Why is like all these sorts of questions that you as an adult sort of, your curiosity tends to shift away from that sort of naive curiosity to something more, I guess, complex.
Yeah.
So I was curious to learn as well, like what is your philosophy to asking these questions? Like how what constitutes asking the right questions? Is that sort of stepping out that box of conformity? Is it like do you have sort of maybe a go-to approach?
I mean, a part of it is so I don't know which part of this is transferable to like AI models, because they are really different. So sometimes we tend to think, oh, they're really like us, but no, they learn totally different than we do. So, but for human, I think there is this strong will, and you see that in every researcher, a good researcher, and it's a very common point with also some very successful entrepreneur, or it's like they really want to do things differently. They really want to explore the thing that's outside of the most probable or like most likely thing. They want to play against the rule. They want to challenge some of the rules. And that's something I was really lacking when I was young. I was like really following the rules all the time, very perfect students. Professor were always very happy with me, no problem. That's not a good thing for wanting to change the world. And that's a hard skill to learn. I think it's a skill to learn, but you can learn that thing. Yeah. And some people have that naturally,
Right.
Since they're young, they're very iconoclast and come on. Yeah.
Do you think college prepared you well to kind of, couldn't go break the rules or like seek a non-conventions or?
So I can only speak for French education.
Okay.
It does not prepare you very well for that.
Yeah.
It does in a way. So I think there's two ways you can do that. It's maybe like a U shape. That's just something I make up now. But when you were speaking, I was thinking that's pretty true. Which is sometimes when you start tackling a new field, you have this first thing where you have a lot of interesting questions because you don't know anything. So you're very free. And so I think a little bit like children, you're very curious, you're ready to ask crazy questions. And then you have a deep, and then you're in a valley where you feel like now you've covered it all. And basically you're less inventive. And I think if you pass this, then you reach maybe the Einstein level, which is, the field, because you also see some old researchers that actually still have very interesting ideas. I think it's because they pass this valley and they're again in this thing where you actually digested all the knowledge of the field, but now you're ready to ask good question because you build on top of the knowledge. But it's tough to reach this outside of the valley. I think. Yeah, a lot of people stay in the middle.
Yeah, it's like gradient ascent. You want to maximize your.
Yeah, you can't be at the valley though.
Yeah, you should not stay in the maximum probability valley.
Yeah. So your Magic Sandbox project for your son's birthday went viral about 5 years ago, landing on Reddit's front page. How did the experience shape your approach to open source projects, such as transformers and dataset libraries at Hugging Face? And how did it, kind of start shifting your journey into just creating things in computer science?
Yeah, a lot, huh? So it's now 9 years ago because I did that during my parental leave where I got my second child and she was just born 9 years ago. And that was a gift for my first child as like fun gift.
Yeah.
And in a way, it became kind of a little bit of a blueprint for many projects at Hugging Face, which is funny because it's not at all Hugging Face thing. But what happened is I built this stuff also because I had this idea about how I wanted humans to interact with this. I wanted, to have this. So just to explain what it is, it's a big box of sand, and there's a project on top that's quite high, and it's project color that depends on the height. So you have like this kind of dynamically cartographic colors. So for instance, you can make mountains white, and then you have water if you want, and when you move the sand, you see this changing, and it's very fun. It's very fun to see. Yeah. It's like a computer interface, but it's all made of sand kind of thing. So it's like a non-flat screen way to interact with a computer. And we made also some fun games where basically you have some animals that are walking, and when you move it, they're like, so they got in the water and there's problems, and had a lot of idea. Yeah. And so when I built it, I was like, that's really cool. It's very fun. Yeah. And so I actually totally destroyed it again. And I rebuilt it slowly by taking pictures step by step. And I made like a full tutorial to explain how you could build that at home and what did you need. It was pretty cheap actually, because you just need a piece of wood and a bit of sand and a beamer basically. And this went viral on Reddit. That was the first time. Yeah. And so that was the first time I understood actually people like when you do that, when you explain how you can build something cool themselves, and they really get excited. And a lot of projects we did at Hugging Face, and a lot of the open source philosophy is also a little bit that, like, there is this cool stuff, and because it's open source, you can actually build it yourself for free. Like, you give it and do the nice experience yourself. So
Lego blocks.
Like what?
It's like Lego blocks.
Yeah, exactly. Yeah. And I love. I think Lego and this type of direction is also super interesting for physical thing like robots. I would love to build robots also myself and feel like they're actually something that I own, that I know how it is. I assemble the pieces, and I even actually train the model myself, so I fully understand this thing. Yeah. And so that was also the first time I discovered you could actually add a bit of impact on the world with something you program. So most of my previous software were just, internal thing I coded on my computer, but I never shared them with anyone. So the first time I was like, oh, actually, if you share it, people can really react, and then you get a lot of people reaching out. Still up to date.
Wow.
So get one, I think it was last month, someone say, I cannot install the Magic Sandbox. So sorry, I just don't maintain it anymore. It's like 9 years ago.
Yeah.
So you mentioned robots. I'm curious, have you heard of Figured AI?
Yeah.
So I wanted to ask a note on, constructing robots and just in general. Do you think that potentially like open sourcing robots could be dangerous given that, you know, let's say you have a robot that's not really able to distinguish between right and wrong. And it comes to the point where, just do whatever you tell it to.
I don't think so. I think I even feel safer with an open source robot next to me because I feel like I can open it and I understand, right, what's inside. Otherwise, it's really hard to trust the robot vendor.
Right.
Or even anyone who touched the robot, actually, because you can change hardware, right? It's not so hard to hack into stuff. So I feel like if I build myself, and open source also has some nice advantage. So for instance, you can run for LLM, you can run locally, you can maybe change it, adapt it. So there's a lot of reason I would feel much safer with an open source robots at home than kind of a black box closed source robots. But maybe it's also kind of just philosophical thing. So
I was thinking about Frankenstein, where the guy ends up making a monster.
I'm reading the book right now.
Oh, yeah. What a coincidence.
Yeah. It's very interesting. It's very slow as a book.
Yeah. Okay. There's definitely a lot of very interesting points.
Yeah.
That do come.
Yeah. It could be, but I feel like so I started reading the books, really thinking. We do it because we want to make an art piece on AI. With it's a side project. It's not Hugging Face, but I have some artists I know well, and we try to use art to talk about AI and also to have people. So last year we did a performance where people would interact with an AI, and it was fun. Also, this AI was local. Running, I programmed it. It was learning so fast, answering so fast that people thought there was a human. They were like, "Wow!" When I asked ChatGPT, I need to wait for the latency, and because it was local, and they didn't believe it was an AI. And so now we want to make something around Frankenstein. And so I was reading it, thinking it could be a good metaphor, but more and more I think it's very different. AI are actually very different from basically creating life. That's a part of this piece I wrote also about AI scientists. I think they're really heading this direction of being very useful assistant. But I don't feel like they have any. For instance, you have this discussion of consciousness in AI, all of this. I'm very down on earth. Feel like they are like a bike. So if you turn the pedal, the thing works. If you stop turning, there's no token coming out. You just stop. So it's not human, right? It's just you turn it there, but if you stop turning, stop working. So it's hard to imagine that there is like anything close to consciousness in them.
Yeah, exactly. No, I definitely feel the same way. Like AI sort of wasn't once a zygote. It didn't sort of experience that wealth of experiences that humans do experience as they grow up. It's sort of, you just take the data, feed into the model, and it learns these like patterns and recognitions. But I think one really interesting question that I've seen sort of surfacing around is whether or not, on the topic of consciousness, can AI dream? So I was curious to perhaps,
so what is a dream for you?
A dream, I think, for me would be, like sort of having some sort of recollection of memories, like resurface, in the future, or like, I think the way I would sort of like think about it in terms of AI would maybe be like RAG, or maybe like having, some sort of memory being carried on or being focused upon as you're learning to maybe generate new responses. But yeah, I was just wondering like if you have maybe any thoughts on whether or not you think AI can like fundamentally dream, or if that's even like applicable maybe in the field.
There was some algorithm like the wake sleep algorithm. Things where we try to make things that there's a little bit. I think dream Well, I mean, the way at least I understand them is they're really this part of memory process where you digest thing and try to maybe simplify or take away what you want to remember from
Right.
all the experience of the day. Maybe there is a lot, maybe it's wrong. It's very, and so we could have this in AI, right? We could have and maybe we'll go there where we'll process the thing and try to extract them. And maybe some post-training thing that we have right now, for instance, when you ask the model, you generate a lot of long reasoning chains, and then you use them to train another model. Often could also be like self-training. Sometimes you filter, you keep the best one, and then you train a model on this. Maybe it's kind of a way of doing what sleep is doing, right?
Yeah.
You make the pre-trained model dream, and then you say these are good dreams, bad dreams. We classify them ourselves, or like with GRPU or something like that, and then you use the good dreams and you train the model on them to change the memory of the model. And maybe that's the closest analogy. But what we don't have a lot today is model indeed with stateful memory, right? So we have this context window for sure, but it's not very digested. There was a lot of work on compressed contexts. There's this infinite memory transformer not so long ago, like last year, something like that, where you try to compress the past context. But it does not work really well. So I feel like we are trying to project some ideas that humans have on AI. So no, we don't see that so much.
Yeah, I was thinking hallucinations, but that doesn't necessarily, fall into the category of dreaming. Yeah. But there are more and more tools, because if you look at brain activity while someone's, dreaming, it's significantly different from, when they're not dreaming. And I think given that we're at the core of what a, machine learning algorithm or neural network is like a neuron, I think there's still something to be discovered there.
Yeah, I would argue. Probably. Yeah, I still think it's very surprising that we have machines that show so many things that are similar to human intelligence. Well, they are created in such different way. And it's amazing.
I think one way I love portraying it is sort of this is from the book called GEB, Gödel Escher Bach, where, you're animating the inanimate. So in a sense, this world of computation is, run by hardware and all these beautiful abstractions.
Yeah.
And yet you can sort of animate it and give it reasoning, give it these quote unquote thoughts or memory, which I think is beautiful.
Yeah. I think you're right. Yeah, I see this a little bit like this as well, right? So we have quite simple rules in the end, right? Matrix multiplication, I think, but they create a world of complexity, and that's I think what Douglas also show in his book. Like you have something pretty simple, but like it can actually transform. Then you reach all this loop inside loop at least. But the basic ingredients and most of his research in AI was around, we start with very simple thing and we just connect them. It makes like this complex system basically that we can't really understand. And AI is exactly that. So it's very similar to what I was doing in my PhD also, which is funny, which is condensed matter. So that's the transition of matter. And basically that's how it works. So you have very simple rule. I mean, not super simple, but like rules on how like the constituents of matter interact. But when you go at large level, at a very high view, you see this phase transition where something starts to crystallize and you have like organization that appears. I think that could be one way to, maybe one day someone will study how the matrices or the activation evolve during training with kind of this statistical physics approach and see like phase transition where the model start learning something. I think that could be one way these things are actually working.
I definitely think open source as well is a huge way to accelerate the way people can do that. And we'd also love to discuss more so about the starting points for Hugging Face. Hugging Face first started off as a chatbot that mimicked a teenage friend. Can you tell us more about how this idea came to be, how you maybe pivoted away from it, and sort of how the name Hugging Face started?
I think this idea started really as a very long-term idea of my co-founder Julien. He really wanted to do this kind of virtual animal or virtual girlfriend or virtual being, basically, that you could interact with. And then basically we all three kind of had this this dream that we could build it with the technology of 2016. So we explore with many ways. So Julien was building this, Clem was finding money to pay for the team and trying to build this thing and see how it interact with user. On my side, I was working a lot on, can we use this new AI technique to power this thing? So at that time was LSTM, not transformers yet, and trying to make this work, but it didn't work at all. It was like, not enough. We didn't have enough data at the time, but we were not really aware of that. And basically when the first, what doesn't really have a name anymore, but it was called transfer learning. So this idea that you would pre-train a model just on a big bunch of data, and then you will try to use it for whatever task. And basically GPT-1 was really the first one that we used. When I started playing with GPT-1 and trying to make it behave like a chatbot, and it really worked a lot better than our LSTM because it was trained on a lot more data than what we had. That's really where I started to click, and I was like, there's something with this idea of training models. And so I started to explore that a lot, and I decided to compare models, and for that to make a library in which there would be a couple of models that I could compare. And this library became extremely successful in all the AI researcher world, which was quite small at the time, but that was the first time we got a lot of interest for something we were building. And so basically I kept building this library, which became Transformers like long time ago. So it was 2018. And people kept getting super excited about this. I did GPT-2 when it came out. And so a couple of months after that, basically when we were supposed to raise our Series A, we were like, okay, there is this virtual, it was virtual dog at that time mostly, I think, that we had. That's actually really difficult to make work. It's working a bit, but it's often out of its domain, right? And then it's answering anything. And we have this thing where there's a lot of excitement. There is like exponential interest. Maybe that's the direction we should go, right? So that's when we decided to pivot. But we kept kind of like the funny name that we had, which was Hugging Face. We really wanted an emoji.
I love the emoji.
The game was made for like millennials, like young adults. We wanted something fun, just very non-serious. So we kept the emoji. And I think we kept the big idea that we wanted to build something used by many people. So it ended up being more like a open source library than a game, but I think this general idea that we want to make something that a lot of people love to use is really the common point between the early and the current Hugging Face. Yeah,
it's a really interesting backstory.
Yeah. A lot of big companies started as game companies. Right, it's a very common thing, right? Slack or like.
Okay, I didn't know that. Wow.
Yeah.
When and how did you meet Clem and Julien?
So I knew Julien for a very long time. We were playing the same music band together.
Wow,
Julien is
nice.
a bass player, and I played keyboards. So we always kind of kept in touch. Yeah. And Clem and Julien, they met us at a meeting, entrepreneur meeting, where you're looking for co-founders, basically, like a speed dating for
nice.
Yeah.
Cool. So now we're going to move on to like LLMs, agents, and regulations. So in one of your Hugging Face blog posts, you talked about the importance of tokenization and reasoning and mathematical capabilities of large language models, particularly like right to left tokenization. And we're curious, how do you see tokenization impacting future scientific and mathematical reasoning in LLMs?
Oh yeah. I think it's one of the things that's. I mean, the trick to making LLM, it's not. At least that's really what we're trying to do at Hugging Face, is explain it's not rocket science. There is often not very complex things, and there is not a lot of math in the end. But you need to be very careful to all the details. That's all the details matter. And tokenization is usually the first one. It's like how you transform your text. And if you're not careful, if you're not looking very carefully, what do I put in? How does it get out? Can it actually do the things I want in the end, given how it's beginning the process, right? If you don't get tokenization right, you're just doomed. So I think it's very nice. And it's quite interesting that Karpathy did a very long video on tokenization. I think is a good. But there's probably still like very simple thing that people don't pay enough attention to. I think the tokenization of numbers is a good example, right? You want to group them. Numbers are funny because you read them, you start by the most important thing, and then you end up, and usually it's more like you start by the details, and then you rise to the most important thing in text, or like, and so they are slightly counterintuitive for models, the way they're written, and they're written left to right, but they should be read right to left mostly, right? And so, for instance, grouping numbers by 3 is also very helpful because we often work in millions, tens, thousands, etc. And so we did the work with interns on does it have an impact? And it does have an impact. So yeah. So sometimes when we say, "Oh, these LM are bad at math," it's just that we are not helping them, right? We just basically, yeah. Yeah. But that's one example, right? All the chain, basically, you can take your whole transformers from the text to the end, and you should really follow each thing, each level, and make sure that you're really like say, okay, are we doing here the thing that we should be doing, and be very, very careful. Yeah.
So spend more time sharpening the axe before you actually deploy the model or build the model.
Yeah, a lot of time diving in this. But I think right now you have some pretty solid recipes on tokenization. Right. So if you follow the good recipe, and we explain them in, for instance, we had a lot of work on FineWeb. Recently, we did a lot of work on math as well, and we explain what you should be doing. Yeah.
So there's, companies like Replit, Vercel, and Cursor that are making programming way easier than ever before. I don't think we're yet at a stage where, you can ask for something to be really complicated to be coded and it'll just be like, coded right in front of you. I'm just curious, do you think that vision would happen in like a couple of months, or when do we think we're going to reach kind of like AGI for coding?
I think coding is one of the easiest field, right? Because you can also have all this nice loop where you actually, you process the outputs, you give back the error to models, this automated thing. You can generate a lot of code. Definitely, it's also very structured. There is clear, you can have clear tests where you say this is good or bad. So it's very well. It's maybe the Go or the chess of reasoning. It's like the rules are clear, the field is clear. You can say if you won or not. And so I would be surprised if we don't reach a very high level, like next year, if we're not really a very, very high level. And we'll keep climbing. The metrics, the evaluation is very easy. You don't have, sometimes you have weird proxy, so you're maximizing something that's not exactly what you want. But in programming, I think you can also be pretty well aligned. So yeah, we'll keep seeing models climb on this thing. Yeah. Now the question, is maybe, can you explain at a certain level of complexity, can you explain the piece of software you want to build in a short sentence? Or is it even possible, I know even for me, sometimes I need to start coding a little bit something to really know what I want. So maybe the problem will start to lie in the human. How do they even know what I want to build, right? Before it's built, it's asking me, hey, can you? Yeah. So
I actually want to touch on that. You mentioned, how do I know what I want to build before I build, right? Shyam Shankar, the CTO of Palantir, just actually came and gave a talk like about an hour ago for CS153, the class we were talking about. And he was mentioning that, a lot of young people nowadays are making software that are not really solving big problems. They're just kind of like, existing there. I was curious to hear your take on, do you think we're producing software at like such a large scale that's not very useful? I've come across many people who kind of are holding a similar view, and I think this might become more prominent, as you mentioned, like once we actually reach, coding AGI.
Yeah, it could be. There is also this idea right now that we'll produce more disposable software because if it's so easy to produce, you produce, all the time, and you don't really care about the quality or even whatever. And so it seems to be the direction we're going in for sure. Maybe less of this crafting that we had, like a very artisanal crafting, a beautiful piece of software, more like. I think there is part of it for sure but for the rest, like, are we tackling the big problems? I think the problem is not so much in which software you're making, but more like, how ambitious you're thinking, or sometimes it's also a lot of people also just want to make, for instance, startup, but they don't really want to know what, so they're taking the first problem they see.
We discussed this sort of. I love this intersection of art and computer science a bit.
Mm,
The whole reason we call the podcast starts is because of STEM and the arts.
mm.
Growing up for both of us, we saw a lot of really, really cool intersections between computer science and art. Um, so I guess my question to you is, how do you see art in maybe your everyday life, or how do you see art
Mm.
in Hugging Face, or what does art in this sort of computational domain mean to you?
I think it's very connected
Yeah.
because overall, I think art for me is also, well, that's a form of art I like, but it's also really about the interaction of someone and an object. And this is
Exactly.
also what I design when I build library, right? I think about the interaction of someone and something I'm building. So the frontier is very tiny. And I see a lot of difference between both of them. I think art, maybe you take a bit more time. You can craft something that doesn't scale at all, that's absolutely unscalable, but just because you're building this one experience for one specific thing, so you can go a bit crazy. And in software, often you want still to think about scaling the thing in a way or another, so that millions of people can use it. So that's the main difference I see. One is still very artisanal in the way that you build it, and the other one less. But for the rest, it's very similar. And I think art is a nice way to explore, the frontier of what you can do in terms of human-object interaction.
Yeah.
So, for instance, I do a lot of robotics as well at Hugging Face. We have a big, growing robotics team.
Nice.
It's going to grow a lot as well. And I think a lot about robots also as cool stuff for potential art or performance or way to interact with humans. I think in both things, in art, at least the one I like and the one I try to do a little bit, which is not really art to be honest, but just I try to find this like wow factor where people are like, "Ooh," like like changing something, or like I'm like, and it's when you think about that, when you want to build a very nice product for a startup, that's also exactly what you're looking for, right? You're looking for something where user will be, wow. It's like,
It still amazes me today. You open your iPhone, you open the camera app.
Yeah.
It's almost like your phone can see the world,
Yeah,
right?
yeah.
And it reminds me a lot. I think about this quite a bit as well. There's a really famous saying that any sufficient advancement in science is indistinguishable from magic.
Yeah.
And there's so much that we truly take for granted. Like right now, this recording, there's so much behind the scenes of these ones and zeros that we don't have to really dig too deep into. And I think a beauty of like the constant innovation we're seeing in society really is open source. And so, we both use Hugging Face quite a bit, and we're very thankful for all the work that you and the team have done with Hugging Face. But also love to learn perhaps a bit more about more broadly the future of open source. We're seeing a rise in the use of open source models for harmful purposes as well, ranging from deep fakes to misinformation as well. So my question to you is, how do you balance the importance of open source to benefit society in terms of encouraging more innovation, encouraging more collaboration, while also, sort of instilling these guardrails to protect society?
Yeah.
At the same time?
Yeah. So there's many ways you can tackle this question, and that's a big question in open source. I would say overall, and there was a lot of discussion over the past year, maybe 18 months around this, right? Started, I think, with all the existential risk question. Then there was a UK safety summit where everyone like really dive in like how dangerous AI could be. And we talk also a lot about open source and should we give everyone this thing for free, and can they not like do cyber attack by modifying the models, or like do bioweapons in the hands of everyone, or like a lot of this question, and even like just model an open source model being free to leave any unclosing place we would have put it because we just put it on the on Dropbox or Hugging Face. So my general feeling, and I think a lot of people agree, is for the today performance of model, it's okay. Like I don't see anyone saying open sourcing Llama was a big mistake in terms of safety. It has been used for like very dangerous things. So I think nobody says you can create bioweapon with Llama. So I think it's okay. I still think for really frontier model, you want to be careful about what you can do with them. So I think it's nice that closed source is mostly still really around this frontier model, and probably for the new kind of frontier open source model, we should also, start to put a battery of tests, basically safety tests. What can you really do with this model? It would be nice. We talk a lot about this safety institute for closed source model, but I think right now we should also maybe explore for open source model. But this being said, I think if you take just open source and risk, my very high level view is that the axis of openness, so it's because closed source, open source is also a full spectrum of thing you can open source. And it's not just black or white. It's like actually you can open source more or less. You can open source the weights. You can just don't even give access to the API. Some models nobody has ever touched, like Flamingo or some DeepMind research. You can't even try them, right? So even just giving access to an API is something like you're a little bit open. To the full open, you share the data, you share the training code and everything, which not a lot of people are doing, I would say, except us. But I think this whole axis of openness is mostly really orthogonal to the axis of risk, which means that basically the more open you go, you increase both risk and benefits, right? And that's the whole story of open source codes, which is when you make like your operating system open, you give a lot of room, a lot of access to very confidential things to everyone. So that's dangerous. But also you give a lot of room to fix it to all the white hat hacker, for instance, will dive in it and try it. So overall, I think taking lesson from code, I feel like the safest piece of code we have are still the open source battle, tested code. And I feel like that's why that's the core of enterprise servers is Linux and not Windows, which is closed source. I mean, there's still like enterprise Windows, but I think it's really, people have generally been thinking that open source is worth the danger because it brings this added resiliency and battle testing. I think it's probably a bit the same for AI models.
Exactly.
Like a good AI models that a lot of people have been testing and experimenting with, and maybe even like exploring interpretability method on top of it to understand how it works. And all of this will be better than like a black box thing that we have to trust it's good just based on who made it, basically. Yeah.
No, I definitely believe that the benefits do outweigh sort of the other side of the spectrum.
Yeah.
And in the future, I'm very excited to sort of see how open source will continue to grow more and more. And it makes me wonder, like sort of as a society in general, if we go back to, the beginning of America, a lot of these like local elections or the democratic elections. Something we're also discussing in class, like at school over here, is with the rise of these algorithms that might be controlling so many important decisions such as jobs or et cetera. Do you think there will be a point where society will itself have to democratically like elect
open source itself
or
system? Yeah, I think it could be. It could be interesting. In the end, you would like to know more. I think to have as much transparency as possible, and then obviously you can take advantage of that. But then it will be fixed, as well. We'll see, like, hey, actually this loophole it was visible, so now let's fix it. So I think it's a bit of also having I think open source has this very humble approach that you might make mistake and that somebody will notice them and then you just fix them. It's a very humble thing that we're not creating perfect thing. It's like work in progress. And society is work in progress, right? Yeah. Imagine if you could not read law, right? If it was like, it's all closed source, but you did bad things, so now you go to jail. Like, that'd be really weird, right?
Yeah.
You would much better be saying, okay, this is all, we can read it and we can know about the rules that governs our world.
Yeah, that's the beauty of it. I think it's an ongoing process of iterations or, somebody from across the world will like maybe push something and you can actually see a change and like, oh, that's a great idea that I didn't think of.
Yeah.
And I think it's beautiful to have everybody sort of collaborate on this.
Yeah. So we see that a lot at Hugging Face because every time there is like a very popular model has come, you have like 1,000 derivative models, people exploring, hey, how can I extend the context? How can I adapt it for that? How can I make it now a reasoning model? And so, and that's really cool, I think. And then a lot of these things, for the most popular, they come back then in the next iteration of Llama or like DeepSeek or
When DeepSeek came out, so I know I was keeping track, like Hugging Face quite like, quickly open source. And it was like really exciting. I was just curious, what was the internal reaction, within the team when DeepSeek first
the thing is, the model was out already for quite some time when it really got visibility and traction. It's been out for since the end of last year, and also we've seen the DeepSeek model getting progressively better and better, right? I think the first moment we really noticed this team was, the math model that was almost 1 year ago was really good. And then when O1 came out with this first indication of test time compute, you let the model think and you actually increase the performance. And just 1 week after, DeepSeek had a model. So obviously they were already training it, right? Because it's so fast, you don't have time. So they were really already working on that. So like, oh, this team is very special. What's really surprised us, and I call it the ChatGPT moment for open source AI, was how everyone became aware of open source AI. So before that, you had to be in AI to really understand that there was different type of models, closed or open. But for my parents, I think they were like, this is all AI, I don't care. But suddenly people who were really not AI builders were like, there is this open source thing, and what does it mean? I can download it? Okay. So that was really this shift in public perception, and a lot of people, just like ChatGPT brought AI in the mainstream, I think DeepSeek kind of brought open source AI a lot more in the mainstream, which was great for us, I would say, because we became suddenly people were like, oh, that's cool. And there's a platform with 1.5 million of open source models. That's so cool.
It's really exciting. So, on the note of open source models, in an online interview, you also mentioned that small open source models, and this is more about small LM2, are better than larger open source models just because they reduce the AI carbon footprint and reduce latency overall. I was curious, so, with still like billion parameter models being developed by a lot of frontier labs, do you think that these small open source models are, eventually going to kind of win in the end or gain a lot of traction, or how do you see us balancing between the small and the large open source models?
I think you will always have to. You will always have the big one. They have a lot of interest, the big ones as well, right? You can really explore the frontier of capabilities. But what we discovered the past 1 year, 1.5 years, is you can distill a lot of this performance to much smaller models. And then it's cool also because they can run on your smartphone, they can run on your laptop, they can do a lot of things like a 600 million or like a 2 trillion parameters model can never do. It's just too big for now. And so this I think is very nice. I really like this idea of models that are maybe not able to. So we were talking about Einstein model. They're maybe not able to invent general relativity, but they're still like good enough to really understand the context of what you're asking to, answer intelligent in a clever way. A lot of useful question. And then they're very local. So it's cool. You have no latency. If you don't have access to the network for whatever reason, you're in a plane or just here on the world, they still work, right? That's another thing I talk a lot about, which is as the technology AI is more and more embedded everywhere, and I think it's really the direction we're going, we want to be resilient to a lot of like issue that can come. And reaching, this data center that's, I don't know where it is, but is with one issue. Like we don't want to depend all the time on all these things.
It reminds me a lot. I think Jensen Huang also came from one of our classes, and we discussed sort of, in the future having this sort of AI scientist. And I think as a human being, you sort of have this moral framework of, still like questioning conformity, and like questioning what would be a good experiment. If I tweak this variable, if I change this variable, if I just like look at a different axis of the question, or like just moving in a different direction, what could be the possible result? And a lot of it ends up being, trying and failing, iterating, and eventually you'll come across something that like does work or gives some sort of indication. On the note of sort of, these agentic systems being able to, like in the future, suppose we do have like really robust agentic AI scientists. Are you concerned about potentially the ethical implications of dangerous experiments or potentially harmful experiments in the future?
It doesn't change fundamentally because I think there will still be human that decided to, plug this robot or like actually make it do something now. We'll just, instead of finding the gun, we'll find the person that, put the gun in the hands of the robot. Then there might be more complex scenario, but I think for a lot of them, you actually can make a parallel to a situation that's already dangerous nowadays, and you can look how we deal with that in society. There's a lot of very dangerous situation already in society, and can't deal with them, or most of them.
So as a follow-up question, as more larger models are being developed, how do you go about viewing alignment for the models that you're open sourcing?
Well, I think alignment is improving very well, like as a science, and even now, what I was saying in my essays, we might be aligning them too much. Like we might be too much aligned. Like they're very obedient. Right now, you can convince them of anything almost. So I feel like people are a bit less worried. I mean, there's still some people. Definitely, if you interview one day Yoshua Bengio or Joe Pinton, they're definitely Yoshua is still very worried about self-conscious machine. I don't. Yeah, on my side, I don't. You have to build. It's since we don't have this machine, you just see what you believe in as a future. I just believe these are just tools, basically. Which Yann Lequin is also a big advocate. I mean, they're just tools. Like like cars were very likely very scary in the beginning, and people were probably like, "What is this thing?" And I think we have a little bit of the same with our AI models, but in the end, it's just a tool, right? Nobody's really scared about cars anymore.
AI models driving test.
Yeah, models driving test. But I do believe I like a lot interpretability work and like constitutional AI. And there is also this new idea that maybe reasoning models are even better at following constitutions. So this is actually a positive thing to have more smarter models. Yeah, mostly in line with this type of work.
I also wanted to ask, like, another question, just on the note of generally, like, being an open source company, does this topic of, competing in terms of like financial incentives with closed source companies, often come up in, whenever you have team meetings, and how do you go about, still maintaining the open source, community and brand, given that there's many other, closed source labs pushing models?
Yeah, it's also a bit difficult, but it's a lot easier now. I feel like 2024, 2020, we had a moment, right, in particular where everything was starting to be very closed around GPT-3, and then there was a lot of startup appearing. They were all closed source startups. Cohere was fully closed company at first. Now they are a big open source builder. AI21 was also really closed at that time. We were like, okay, what can we do, right? And there were all this idea of how expensive it is to train this model. I think this ship has sailed, basically, and people understood, and DeepSeek is another example. You can train very good model. I mean, they're not frontier-like, but they're very close with the budget, basically, which is surprising, right? So
Object for today.
yeah.
Yeah.
So you have on the one hand DeepSeek, you see it's trained for $5-6 million, probably a bit more, right, with all the experiment things, but like this, and then you have Stargate, you have $500 billion, and there is this bit of cognitive dissonance where you don't really know where the truth is, and I don't have the answer right now.
We were also very fascinated by your personal journey with Big Science and Bloom, and sort of bridging the gap between industry and academia. So Big Science's mission is unique in that it seeks to bridge the gap between academia and industrial labs. Your book on NLP with O'Reilly, videos on the Hugging Face YouTube channel, specifically NLP with Transformers, is really, really exciting. And I really love how you're working towards making AI more accessible for people from all walks of life. John and I also both loved Andre's Zero to Hero playlist, and we also really enjoyed your video with NLP with Transformers. My question is, how can we make AI more accessible to people from all walks of life? And do you think that there is still a significant gap between industry and academia? And if so, how can we close this gap?
So I think we do a lot of work on maybe bridging the gap between, I would say, what the master level person know and what the expert training models in industry know. And like just last month, I don't know if you saw, but we released a full book on distributed training of models, where basically we explain how you should train your models on 1,000 GPU, which kind of distributed training you should use, all of these. So I think here we try to do a lot of work. Hopefully it's useful. I think Andre is doing these things as well. And the main part where I think it's missing is just before this. When do you start from, like, really, I don't know, I'm a law student, or I'm a social science student, or biology, or something that's no relation with software coding. Where do I go from this to the entry level to understand the video we and Andre are doing? I think that's where something's lacking. If you want to do things, at least that's where I wish we would do more. Yeah. But I still not. I think it's a never-ending story. But it's also maybe the most important thing in the end, because if you explain to everyone how to build this model, I often say my big vision for a very long time in the future is I would like AI to be the knowledge around AI, like how we do this to be kind of a common good of humanity. Just like I was able to study physics just by reading books. I didn't have to ask anyone, like any company, how does relativity work, because it's their IP protected. Everyone can just take a book and you read it and you understand about the secrets of universe basically and how it works. That's really cool. And if you think intelligence is a very important thing in the universe, which I believe everyone should also be able to take a book and read how do we make intelligence system, right? How do we train these state-of-the-art models? It would be very sad if only like a handful of people know the secret recipe for intelligence. So that's one reason it's a big part of what we do. And the other reason is the more people know how to do that, the more people will train models and will actually open source models. So I think it's good also for our platforms.
Yeah, it's really interesting you brought up the notion of democratizing like intelligence. Just because I think we're entering an era now where, going back to like tools like Vercel and Replit, where your wealth is kind of like a function of your ability to use these tools. There's people who are shipping apps and making money off of them nowadays, and it's almost like a political power as to like whether or not it's a more authoritarian society where only a few people are really like in charge of the models, whereas everybody else is kind of like able to kind of voice their own voice.
Yeah, I fully align with that.
So a lot of complex math and AI and ML algorithms and techniques hold deep connections to physics and like a thorough scientific disciplines. Jagan and I are like AI machine learning self-learners. We I think started self-learning, deep learning when we were like around 15 or 16 in high school. Really loved the field. So we were inspired by our journey in self-learning through books such as the Deep Learning book, the Book of Why, and various online courses. So we're curious if you could tell us more about your self-learning journey and I guess from the French side as well. Do you think it's so important to go to college today?
Yeah, so I studied in a very traditional way. So I took books and I read them cover to cover. Like very good student, right? Reading all the exercise and doing everything. I think you can learn much faster right now. So my reading book, I have a reading list, which is also a little bit outdated. Though, I mean, it's always good to know more than what you need, I think. So knowing a bit about bias, Bayesian theory, or like probability, it's always good, even if in practice you just do code, right? So, but I think what you should really do nowadays, and it's just really learning by doing. And a lot of people we hired at Hugging Face, it's based on the project they've done, basically their GitHub portfolio, and it's the highest predictor of how impactful they will be. And so I think that's maybe what I would do nowadays if I was to learn. I mean, to be honest, I was doing both. I was reading book, and then I had this small project I had at the time, which was to animate drawing. And so this never really worked in the end, but with neural network kind of thing. So I still had a side project, but I think nowadays you should just start your project and iterate and play with it. Maybe not be too scared by the math. The real.
There's definitely so much to the notion of AI. I think it's so many different acronyms and everything that can often be a bit intimidating when you're just like first stepping into the field.
It's true.
And I think as we're seeing with Replit, Cursor, or Vzer.dev, I think in Twitter, like I mentioned this in the previous podcast as well. There was an 8-year-old who made her own like Replit app. I was like completely blown away. I think it's so cool how coding has become more accessible than ever before. And I think as you mentioned before, this sort of having this sort of AI framework as a common social skill, it makes me wonder that as we go to school, we learn the A, B, C, D, E, F, G, the whole vocabulary, right? Or the whole alphabet. It makes me wonder if in the future we'll have elementary school students like learning Python or
Transformers,
or
GPT,
like all like the fundamentals of AI, because
we should.
I think it'll be
like programming is getting really like very important skills. I feel like AI will be, it's more and more likely, that at least all software developer will be AI developer. It seems like it will be more and more weird to say, oh, I'm a software developer, but I don't do anything with AI, or like I don't know about it. So it will really be all of this. And then if you think that software developing is a kind of a general, very useful skill in life, which it's becoming more and more, then AI will also be like that. Yeah. Yeah. Now the question is, how do you teach AI very early, right?
Yeah.
What do you teach? There's a lot of cool stuff to do. I think you should teach a little bit about hallucination, how you do prompting, how these models are roughly made, the importance of data sets and this type of things. There's a lot of things you should actually teach. And I've not yet seen a lot of classes on that. Yeah.
I think one thing I thought about quite a bit is, we sort of embody a lot of the characteristics of AI in our everyday lives. You've learned to classify objects or classify, like, this is a bottle, this is a piece of paper. That sort of gives a very high level abstraction of, like, sort of you see multiple different examples or patterns. You're able to classify, this is a paper, this is not a paper. And I think that's sort of, if we can sort of convey that more to the youth and get them excited about the fact that we can take this sort of human knowledge and put it into a computer and accelerate that to magnitudes of, insane orders, I think can really, really empower the youth to sort of not get too fearful or intimidated by, like logistic regression or all these like very minute sort of mathematical details.
Yeah, I agree. Yeah. What is very nice from AI as a technology is it's a very human technology, right? It's like very natural to interact with this. It's very like you can write in your own language. It's very often even multilingual. So it's very easy as an entry access to a technology. It's very, very low. So my son, who is 12, I see him, he doesn't even really know how to code, right? But he's already coding just by prompting stuff. Seeing the thing. And I'm like,
vibe coding.
Yeah, vibe coding. Yeah, exactly. When you're 12. It's not even because vibe coding there's a little bit of a connotation. It's more like software developer, right? They're coding a bit fast and they're listening to music, etc. So it's something different. It's coding when you don't even know code and you don't even care. You just want to build the stuff. But something that's close to what you're saying is, I think it will be a generation that will be not scared at all to build stuff because they will know they can do it and it will look very easy for them. For us, we always we think, oh, I could build this, but that's a bit complex. So I need a database, something like that. I don't know if I want to start this project. It will be a generation that will be like, yeah, just start this. Can you code something with a database or whatever? The thing will be there.
Done.
I think, what I'm most excited about, I think in our current society, there's like a distribution of like optimism and versus pessimism. And I feel like with all these new tools and like vibe coding, I feel like distribution is going to shift a lot more to the right. And, a lot of people, even who are not technical, as you mentioned, like a biologist or a lawyer, can start taking, problems they identified in their own day-to-day life and codify that. And that will start changing the whole landscape.
I think this idea of like a very simple to do one-use app, something you made for your very edge casey thing. But just because it's so easy to do, you do it. That's a very game-changing approach, right? To software building and to basically building things.
One more question is, you mentioned the sort of your approach to, books being a huge part of your journey in self-learning. What are your thoughts on, having AI tutors? Do you, because there's a huge debate about sort of having this genuine empathy between you and the teacher, or sort of being able to physically interact with maybe a book or like solve exercises or etc. Or maybe even, getting motivation or inspiration of, one day I would like to, learn math as well, or I would like to maybe, build a really interesting like scientific experiment or model. Do you foresee AI tutors as being sustainable in the future, or do you think this sort of structure between the teacher and the student will always be there to side?
I think you put the finger exactly on the tricky thing here, right? So I don't believe a lot in many of this AI tutor thing, because I think there is something very in a good relation that you have with a great teacher. There is something that go beyond just cold knowledge. There is something like you feel like there is a kind of a level of empathy and understanding that's actually making this click. I think at least that's what I had with my best teacher. Like I was like, wow, these type of things. And I think if we want AI tutor, and if it's just like, kind of a dynamically evolving website, I don't think it's going to change fundamentally the thing. But if we, if we go in this direction, and recently there is definitely some, for instance, a voice interface that feel like they start to maybe have something. Maybe we could read. So there was this very nice book. It's always the one I think when I think like the ultimate, which was Neil Stephenson, Diamond's Age, where they grew up, and there's this book that's actually like a tutor that the kids, the main character reads for years, and like it's a fully evolving story, very complex with a lot of like characters that are actually a reflection of the real character in the book.
Oh, okay.
And it's a very beautiful book. I think it's a big one on education. And I think if you reach this level of complexity, you could have something that would be game changing, where basically someone could be in a way self-educated on almost everything, which is amazing. And I think it's worth trying to build these things. But I think the threshold that we'll need to reach will be much higher than people think. Like to have like very useful AI tutor.
The wow factor.
Yeah.
As you mentioned.
The what?
The wow factor.
Which one?
Like the wow, like sort of.
Oh yeah, definitely. Like you should feel. I think you will need to feel connected to this object. Yeah. Which is, I don't know if it's a good idea or not, but yeah.
We saw Sesame recently, and that was very interesting. How
Yeah, exactly.
like human like.
Yeah. This is the example, I think, of experience you will need to reach.
Yeah. I think what I'm most worried about is like I've oftentimes noticed when it comes to mentoring and teaching, part of it is of course what you learn, but the other part is the fact that somebody like instilled knowledge in you just from their own experience.
Yeah.
And that creates a sense of gratitude and willingness to like help others and kind of pass it on. And I think if we're in a world where everybody is just going to be like, I'm not going to office hours, I'm just going to ask Claude. I feel like the level of help people would offer to other people would significantly diminish.
Yeah. So that's a big question around AI also, right?
Yeah.
It's one of these fundamental social questions, which is, will it contribute to isolate each other even more, right?
Yeah.
And my kind of counter intuition on this is, I think because we'll be able to like have all of this digital experience and also all this fake digital thing, like when basically I think very soon when you call someone, it will be indistinguishable if this video you're seeing is real or not. We could also almost doing that. So I think this will bring us to value a lot more the time just being with a human, because we know it's not fake. It's like a real thing. Well, at least that's my hope. And just like, artists, now you value maybe more going to the concert because, it's very important also for them, because streaming has become, you don't really buy a disc anymore. You're not like, oh, this object is special. You just stream your thing. You don't have this thing. And so when you go to a concert, it feels more special. I feel like
and memorable as well. You physically.
So you move to kind of an experience of connection. And so maybe AI will bring this thing.
Just to clarify, this podcast is real.
We're not AI generated yet.
Though
I'm not sure.
I think our last question to wrap up today is, what are some hot takes or views that you have about the world that you oftentimes encounter people just disagreeing with that view?
Wow, that's a big question. I like to be a bit against the consensus, so I do have a lot of them, I think. But no, like the most recent one, I think that touched many people, was this idea that we are not really on track to make AI Einstein. So a lot of people send me emails after I wrote that and saying, oh, I agree, or I disagree, or I don't know, or like maybe this is the solution. I never got so many reactions. I get maybe 50 or 60 emails at least on this, and then a lot of other messages from like social networks. So that was surprising. But in a good way, I think. Or maybe some people saw that also as an optimistic view. There's also always this question with AI, right? Which is, what does it mean to be human in the end, right? Since we can automate or replace all of these things that we thought were very unique. So what's left, right? So a lot of people also read my essay, maybe thinking, oh, there's still something left for us, at least for Einstein. So I think this, I have a very positive, optimistic view, I think, of the future of AI that not so many people have, or like non-dystopian view, at least. I want a future where, AI make us more human. Actually, we're more happy to be human. So that's one thing. and probably like just also this very positive view of community and humanity. So one example, so we talk a lot about also the danger of AI. And so I had this question just yesterday at the conference. Someone said, you have all these apps, and do people put apps to do bad thing on your website? Like, you have these spaces where you can build an app, and you could do like, I don't know, like a nude fake or app or something like that. I was trying to find an example. I was like, no, actually, you can flag them. There's all like we have whole procedure to filter them, but like people just want to build nice things. Like the vast majority of people really want to build cool and nice stuff with AI. So that's cool. I think.
Yeah. Could be worse. Could be worse.
Yeah.
I mean, there's definitely a lot of, I think there's the potential to change the world with whether it's medical discoveries, whether it's enhancing technology for people that are disabled, and automating speech control with your device. I think it's there's so much positive potential that it's so difficult to ignore that. And I think just as any human being, I think you have this sort of empathetic connection to build something that people will love, that they will use. That I think that fulfillment is sort of a key stage of growth. Which,
That's one thing. One thing I actually love about being on campus here is that everybody's talking about various ideas, and you'll go to GSP and you'll hear the word AI like 500 times. But
even in the gym, you'll like see it's it's everywhere.
I think it will stop being a specific word. We had this discussion with an investor. He was like, do you invest in AI only? And I was like, what's outside of AI nowadays? I mean, this feels like it's a little bit like asking, do you invest in internet companies? I mean, everything is internet company nowadays. Like everything is connected in a way on this. And I think AI will be a bit like that. At some point, we won't even talk about this word specifically because it will be so much of a part of everything that you don't say it.
Great. Well, Thomas, thank you very, very much for being here today. It's been a true privilege to be able to talk to you, and we really enjoyed the conversation.
Thank you so much.
Thanks.
Thank you.